Hello everyone, welcome to GradeUp. My name is Vikas Sir and today I am going to start an introduction of engineering mechanics. Okay. So a very good evening to everyone, and I am meeting you after our class of thermodynamics. So today is the class of engineering mechanics. Last time we met in our 2 or 3 days class on thermodynamics, where we have covered 30% of 35% syllabus of thermodynamics. Okay, and also Shantanu Sir in his previous class have covered some important topics of heat transfer. Okay, so today I am going to cover engineering mechanics. I am going to start engineering mechanics. Now a very good evening to everyone. Those who are live right now, please tell your friends to join this live session so that they can be get benefited from this live session that we are going to conduct on engineering mechanics. Okay, so a very good evening to everyone. Good evening Mohish Sharma, Shankar Naik, Ashil Panchal, Vrishab and Abhishek Shukla. A very good evening to everyone. So today we are going to start engineering mechanics. Okay, now this engineering mechanics is also an important subject for RRB and SSC JE. Okay, and also if you see the different other exams, engineering mechanics is asked in around 5 to 6 marks in different exams. Okay, so same applies to RRB and SSC JE also. Okay, so this is also a very important subject. All right, and this is a basic subject also. So very good evening to everyone and those who have joined me right now, and let us start. Okay, so if you see the syllabus of RRB and SSC JE for engineering mechanics, if you see this RRB JE CBT 2, okay, so the topics for RRB JE CBT 2 are resolution of forces, types and system of forces, and laws of forces. Okay, and further we will see that there is friction, moment of inertia, D'Alembert principle, and motion of projectile and laws of motion, laws of conservation of energy and momentum. So these are some topics from RRB JE. And if you see the SSC JE paper 1, they are equilibrium of forces, laws of motion and friction. These are some topics. Okay, now I am going to cover 30% of the syllabus. That means from these topics I will be covering 2 to 3 topics. Okay, so let's start. Now engineering mechanics, you guys, yes everyone, engineering mechanics you all have studied in your BTech first year, and if this subject is a very interesting subject, because you know that you all have, when you have studied physics in your 10th and 12th, from that physics comes 3 important branches, that is electrical engineering. In mechanical there is thermodynamics, okay, that is concept of heat and energy, and further engineering mechanics is also derived from physics. Okay, so what is mechanics? Firstly, we will understand what is mechanics. Mechanics is a science of study of interaction of forces on a body which is at rest and in moving condition. Okay, so when we study the forces which are acting on a body which is at rest and moving, then it is called mechanics. That science is called mechanics. Okay, yes, so different researchers and different philosophers have taken a very huge interest in this mechanics thing, that why we study forces on a body which is at rest and motion. Okay, so like Archimedes, Galileo and Newton and Einstein, so there were some scientists who have taken research interest in this subject mechanics. Okay, so Newton, as you know, Isaac Newton, he gave the concept of laws of motion and gravitation, laws of gravitation. Okay, and that mechanics is called Newtonian mechanics, Newtonian or classical mechanics. Okay, so the mechanics that is given by Newton is called Newtonian and classical mechanics, and this is the mechanics that have given the laws of gravitation and motion. Okay, and this is the mechanics that we apply in our engineering. Okay, we apply Newtonian mechanics to solve some problems of engineering. Okay, now yes, Ashil Panchal, we will try to arrange lecture for electrical, so don't worry about it. Okay, Now, further, there was a scientist called, as we know that Einstein have given a relativistic mechanics. Okay, why Einstein gave relativistic mechanics? Because Newton failed to provide mechanism of forces for high speed bodies. When bodies are moving at high speed, Newton failed to provide the mechanics for such kind of bodies. Okay, so for bodies moving at high speed, Einstein gave relativistic mechanics. Okay, and further it is quantum mechanics, that is modern day mechanics, and this quantum mechanics was given by Schrödinger and Broglie. Okay, Schrödinger and Broglie. Now, we study Newtonian mechanics because Isaac Newton was the one who have covered a lot of problems related to mechanics. Okay, related to mechanics of rigid bodies. Okay, so that's why the mechanics that we study is Newtonian mechanics. Always remember this thing. Okay, so that was all about the discovery of mechanics under laws of motion, gravitation, and so Isaac Newton has contributed a lot to mechanics. Okay, now what is mechanics and how we classify the mechanics? As the definition of mechanics is the science of study of forces acting on a body which is at rest and motion. Okay, so depending on the body on which forces are studied, mechanics is classified as mechanics of solid, and mechanics of fluid. Okay, mechanics of fluid. Now, you guys know about this. I hope you know about this. Now, how we classify this mechanics of solid? Any idea about it? These solids are further classified into two parts. One is mechanics of rigid body or non-deformable body, and other is mechanics of deformable body. Okay, so this mechanics of solid is further classified into rigid body and deformable body. Okay, now what is a rigid body? Rigid body is a body on which when you apply force there is no deformation. There is no deformation in the body, then it is called rigid body. Okay, and when the body gets deformed and on application of force, then it is called a deformable body. Okay, so I will give you example of rigid body and deformable body also. Okay, now suppose that there is a bar, there is a rod which is attached to some support. Okay, and there is a block here. Okay, now if you apply some force here, what will happen? This block will be displaced. This block will be displaced from its position. Okay, we apply the force, what will happen? This will get displaced. There will be a displacement. There will be displacement, that is change in position. But there will not be any deformation on this rod. Okay, so what will happen? This will be called as rigid body. But what will happen? Very sooner, after some time, this will get deformed. And there will be a change in the shape of the body. There will be a change in the thickness. Okay, so it will get deformed after. So the block will get displaced from its position. The block which is at the end will get displaced from its position, and that will called rigid body. Okay, due to displacement, and this rod will get deformed. There will be a change in the shape. So that is called a deformed body. Okay, now, so we have known what is mechanics of solids, further classified into rigid body and deformable body. Okay, so mechanics of solid is further classified into mechanics of solid is further classified into rigid body and deformable body. Okay, now when we study forces which are acting on a body which is at rest or motion, okay, and the body is a rigid body, then it is called as engineering mechanics. Then it is called engineering mechanics. Okay, so when we consider rigid body for our analysis of forces on a body which is at rest and motion, then it is called engineering mechanics. Okay, and whenever we study deformable body, when force are acting on a deformable body which is about to deform, okay, so that is called mechanics of, that is called branch of mechanics which is strength of material. Okay, so in the strength of material we study the effect of internal forces on the body. Okay, and these internal forces causes stress. Okay, so in the strength of material we are going to study internal forces and their effect, that is on a deformable body. Okay, but in engineering mechanics we are going to study the effect of forces on a rigid body, those bodies in which there is no deformation. Okay, so this engineering mechanics is further classified into statics and dynamics. Statics and dynamics. What is statics? Any idea? Yes. When the forces are acting on a body, such that the body is at rest or moving with uniform velocity, then it is called as statics. That branch of engineering mechanics is called statics. When body at rest, then it is called static or moving with uniform motion. Okay, what is dynamics? Dynamics is further classified into two types. One is called kinetics, another is called kinematics. Okay, so dynamics means motion. Okay, that means when we study forces acting on a body which is in motion. Okay, but what is kinematics? Kinematics is the study of forces acting on a body which is moving without considering the cause of motion. Without considering the cause of motion, that is kinematics. That is, we don't consider the cause of motion for a study, then it is kinematics. And in kinetics we study the cause of motion on a body which is moving, then it is called kinetics. Okay, so this is a classification of engineering mechanics in statics, dynamics, and further into kinetics and kinematics. Okay, so I hope this classification is clear to you all. All right. Yeah, so as we can see your comments, some of you are asking for the classes of computer science and some of you are asking for classes of electrical. Okay, so we are working on it, we are planning on that. Okay, and very soon we will come with some good results for you. Okay, so don't lose hope. We will surely come with classes of electrical and other branches also. Okay, now deformable body, that is strength of material, you will be studying later. Okay, as in the subject of strength of material. Okay, so this is the classification of mechanics on the basis of bodies. Now other classification was mechanics of fluid. Okay, mechanics of fluid. What is mechanics of fluid? When we study forces which are acting on a body, when we study forces which are acting on a body which is either a liquid or a gas. Fluid is either liquid or gas. Okay, then it is called mechanics of fluid. Okay, and this mechanics of fluid is called fluid mechanics. Okay, so there is a separate branch, a separate subject for fluid mechanics that we will be covering. Okay, so this is fluid mechanics. In this fluid mechanics we will be studying that liquids are usually compressible. incompressible, and gases are compressible. Incompressible means when density is constant and density is not varying. Okay, so that branch of mechanics which deal with mechanics of fluid is called fluid mechanics. So this was a little bit classification of mechanics. Okay, so I hope that is clear to you. Okay, now so as you can see, mechanics gave three important subjects. One is engineering mechanics, other is strength of material and fluid mechanics. Okay, so we are going to start engineering mechanics. Okay, now engineering mechanics, we have, as I have told you, statics is the study of forces which are acting on a body which is at rest, okay, or moving at uniform velocity. Okay, dynamics is the study of forces which are acting on a body which is in motion. That is further classified into kinetics and kinematics. Okay, now after going through the classification of mechanics, what other thing is important is that if you see in the definition of mechanics, what I am telling you, a study of forces which are acting on a body which is at rest or motion. Now bodies at rest or motion, that I have given you a classification, that is called statics or dynamics. But what about the force? What is a force? When we hear this word force, what is a force? What is a force? The first thing that comes in our mind when we hear force is when we are pushing or pulling something. Okay, when we are exerting some force on a body, try to push a body or pull a body, that is a force. Okay, so we usually push or pull. Okay, so let me tell you, this is just a one kind of force. Okay, there are different other kinds of forces also, like gravitational force, electrical forces. Okay, and there are different mechanical forces also. But this force, my friends, this force is something, an external agency whose end result is to cause a motion in a body. Okay, so when the interaction is such a way that we cause a motion to a body, then we say the force has been applied to a body. Okay, now is that so? Is that the only definition? Is the only definition of force that whenever a position of the body is changed, then the only force is applied? Do you really think so? Suppose that when we were studying, suppose that there is a ball which is kept on the ground. Sorry, a ball is kept on the ground. Yes. So we can say this ball is at rest. Okay. So is there any force acting on this? So force acts until unless by Newton's second law of motion, force is equal to rate of change of momentum. And that in the next lecture, when I will be covering different laws of motion, then I will tell you about force. Okay. But for now, you should understand Newton's second law of motion gave the definition of force, that is, it is equal to rate of change of momentum, that is F is equal to dmv over dt. Okay, that is given by Newton's second law of motion, that we are going to study in the next lecture. Okay, so a gravitational force, yes, a very good example of force is gravitational force. Gravitational force is a kind of force which is attracting you towards itself. We are always getting attracted by the force of gravity. Okay, so apart from this definition of push or pull of a force, there are different other kinds of forces also. There are different other kind of forces. Okay, so let us understand what are different other kind of forces. What are the types of forces? Now, before understanding that, I am gonna tell you that suppose there is a ladder. There is a ladder, okay, which is, and this is a wall. Okay, now this ladder is inclined towards the wall. Okay, and one person is standing at a point. Suppose this is A, this is B, and this is point C. Okay, and at this person is applying some force, which this is having some weight of 60 Newton. All right. Now, this force, what are the characteristics of a force? This force is having some magnitude. Forces always have some magnitude, direction. It acts along the line of action of force. Line of action of force. And it is always applied at some point, that is point of application of force. So a force is defined by these four characteristics, that is, it has some magnitude, it has having some direction, it always acts along a line of action, and it is always applied at a point. Okay, for in this case you can see that a person is standing at this point, so here a weight, that is force of gravity, is acting here. Okay, now so we can say that this force is equal to 60 Newton. F is equal to 60 Newton. Net force, if it is equal to 60 Newton, direction of this force is vertically downward. Direction of the force is vertically downward, and the point of application of the force is this point, point C. Okay, and the line of action of force is vertical. Okay, so the force has always got a magnitude, a direction, a line of action, and a point of application. Okay, so these are the characteristics of a force. All right, so based on these characteristics of the force is classified into different types. There are different types of forces. So let us see what are different types of forces. So first kind of force is a collinear force. Collinear force. What is a collinear force? Yes. Mohammad Ajuddin, good evening and welcome. Yes. What is a collinear force? When force acts along a straight line. When force acts around a straight line, then it is called a collinear force. When force are acting on a straight line. Okay, when the line of action of a force is along a straight line. What is the example of a collinear force? If you have played tug of war, okay, if you have played tug of war, okay, so in the tug of war, what we do, we apply the force in a straight line. Okay, or if we give an example, suppose that a train is standing on a platform. Okay, so that train, all the forces in the train are acting along the straight line. Okay, so that example of collinear force, that is tug of war. Okay, that is forces are acting in the same line. Okay, another type of force is concurrent force. What is a concurrent force? What is a concurrent force? Yes, when the line of action of the forces are such that they are acting towards a point. Okay, that means suppose there are force F1, F2, F3 and F4. All these forces are originating from the same point. Okay, concurrent means those forces which are originating from the same point. Concurrent means same point. Okay, so that forces is called concurrent forces. Okay, so those forces which act around a point, those are called the concurrent forces. Okay, yes, the forces acting at a point is called concurrent forces. Okay, next force is coplanar force. Coplanar force. Yes, what is a coplanar force? Coplanar means, as the word says, coplanar, when the forces are acting in a same plane. When force act in a same plane, then it is called a coplanar force. Okay, when force act on a same plane, it is a coplanar force. Yes. Now, suppose that there is a plane XY plane. Okay, and there are different forces which are acting on a same plane, F1, F2, F3. Okay, all the forces are acting in the same plane. That is called a coplanar force. Okay. Non-coplanar force will be when the forces are not acting in the same plane. Suppose it is a XYZ plane. So they are different forces, but they are not acting in the same plane. So it is called a non-coplanar force. Non-coplanar force of system. Okay. Now, after understanding what is coplanar and non-coplanar forces, let us understand another kind of force, that is parallel forces. What are parallel forces? What are parallel forces? When the line of action of force are such that they are parallel to each other. They are parallel to each other. Okay. So these are called the parallel forces. Okay. Example of parallel force. What is example of parallel force? Yes. When we see that there is a beam. There is a beam, and on this beam there are vertical forces which are acting on a beam. Okay, so that is an example of a parallel force. Okay, there are different forces which are acting parallel along the length of the beam. That is an example of a parallel force. Okay, this is an example of a parallel force. Yes. Someone is asking about the example of concurrent force. You should think by yourself. If you can visualize around yourself, you can find some example of concurrent forces also. Okay. Yes. The parallel force example is when vertically acting forces are acting on a beam. Okay. So that is example of parallel force. Okay. Next is, now this class is also for the civil engineering students also. Okay, because a part of the syllabus of civil engineering for RRB SSC JE also contains topics for engineering mechanics. Okay, so if there is some student of civil engineering also, so you can also join the session. Yes. So far we have studied about collinear forces, concurrent forces, parallel forces, coplanar and non-coplanar forces. Okay. Now, if we combine these forces, so suppose there is a coplanar parallel force. Okay, coplanar parallel force. How we draw them? Coplanar means same plane and they are acting parallel to each other. So that is coplanar and parallel force. Okay, and what are the example? Yes. What is the example? Yes, someone is asking about the expected date of CBT. As you know that elections date are already out, and elections are going to be conducted around 16th of May. Okay, so maybe after at the end of the May or in the starting first week of the June, the CBT 1 will be held. Okay, so CBT 1 exam will be held in the end of the May or the starting month of the June. Okay, so there is enough time to prepare for CBT 1. Yes. Yes, so coplanar parallel force. What is the example of coplanar and parallel force? So the previous example that I gave you, that is system of vertical forces acting on a beam, that was also example of a coplanar and parallel force. Okay, system of vertical forces acting on the beam. If you see that beam is always acting in a plane. Okay, beam always act in a plane. Okay, so the example of a coplanar parallel force is same, that is vertical forces acting on the beam, that is coplanar parallel forces. Okay, next is coplanar and concurrent force. What is coplanar and concurrent? That means if the forces are acting at a point and they are in the same plane. That is a coplanar and concurrent forces. Okay. Other is coplanar and non-concurrent. Coplanar and non-concurrent forces, and other is non-coplanar and non-concurrent or concurrent. Okay. Non-coplanar and concurrent. What is the example of a non-coplanar and concurrent force? Example is a tripod carrying camera. Okay, that is example of a non-coplanar and concurrent force. Okay. Other is non-coplanar and non-concurrent. What is the example of this? Non-coplanar and non-concurrent. So you need to visualize. So today your task will be, you have to visualize different forces in your room or around your surrounding. Okay, and you have to visualize those forces. Yes, non-coplanar and non-concurrent forces. Example is forces acting on moving bus. Forces acting on moving bus. When a bus is moving, okay, so it is not always the case that the bus is moving in a same plane. Bus moves in different plane or moving car. Yes, Mohit Malviya, you are absolutely correct. Okay, moving bus or moving car. Okay, so the moving body doesn't move in a same plane. It moves in different planes. Okay, so that is a non-coplanar. And also the forces act in different, are not concurrent, because the people which are sitting inside or the passenger sitting inside the bus, they are sitting in different points. Okay, so that is not concurrent. Okay, so the example of non-coplanar and non-concurrent is the forces acting on the moving bus or car. Okay. Yes. So this was all about the forces. Okay. So I hope you have understood the different kind of forces. Okay. Now there are different laws of forces. There are different laws of forces. And one important law of force is a parallelogram law of forces. Parallelogram law of forces. What is this parallelogram law of force? Do you have any idea? Yes. According to this, yes. Ajit Ravi asking a question. Vikas Sir, please guide me the reference book for. Yes, there are different books for engineering mechanics. Okay. When we were in BTech, we studied a very good book of Bhavikatti, SS Bhavikatti, and if you can buy that book, so you can clear your concept. Okay. So also there are different other books. They are by foreign writers, but I should suggest you that if you have gone through our video lectures that we have recorded for the GATE preparation, there also we have covered engineering mechanics syllabus, because engineering mechanics is a subject which is asked in 5 to 6 marks in different exams. Okay, so if you try to consider a good book that I am going to tell you, okay, you can consult some good books, and at the end of the session or in the comment box I will tell you the names of the reference book for mechanics. Okay. Now what is parallelogram law of forces? What is parallelogram law of forces? Suppose that there are two forces which are acting simultaneously as the side of the parallelogram. Okay, if the two forces are acting as a side of a parallelogram, two sides of the parallelogram, so the resultant of these two forces will be represented by the diagonal of the parallelogram. Okay, firstly we should complete this parallelogram. The resultant of the force will be covered by the diagonal. Suppose this is P, force P, this is force Q. Okay. So the resultant of the force will be covered by the diagonal of the parallelogram. Okay. So this is called the parallelogram law of force. Okay, that if two forces are represented by the two sides of the parallelogram, then the resultant of the course will be. Yes, Amit Singh, I suggest you don't use abusive language in our video lecture, because this is a technical course for CBT2 where we don't require such abusive or foul languages. Okay, so try to avoid such languages in my session, otherwise don't need to come in the session. Yes. Mohit Malviya is asking, sir, video lecture on GATE are available up to what period? Well, Mohit Malviya, the video lecture will be available till 31st of March. Yes. So, the resultant of the forces in the parallelogram will be represented by the diagonal of the parallelogram. Okay. So, that is parallelogram law of force. Now, other law of forces is triangular law of force. Okay. What is the triangular law of force? What is the triangular law of force? Suppose that there are two forces which are represented by the sides of a triangle, force P and force Q. There are two forces which are acting as the sides of the triangle. Okay, so the result, the closing side of the triangle taken from the initial point to the final point represent the resultant of the two forces. Okay, so the closing side of the two triangles, okay, which are taking in as the adjacent sides of the triangle taken in the order, then the closing side of the triangle taking from the initial point to the final point represent the resultant of the force. Okay, suppose the angle between these two forces is theta. Angle between these two forces theta. Okay, so by cosine law, now we can find the resultant of these forces by two methods. One method of finding the resultant of the forces is by graphical method. Yes, one method is graphical method and other method is called analytical method. Okay, so by analytical method, the resultant of the force, that is resultant of the force that we have found by the triangular law of force, this can be found by cosine law, and by cosine law the resultant of the force will be equal to P square plus Q square minus 2PQ cos theta. Okay, where theta is the angle between these two forces. Okay, so this is called the cosine law for a triangle. Okay, and by using this cosine law you can find the resultant of any forces which are acting in a triangle. Okay, but they are in the same order. Okay, so this is the resultant cosine law. Another is the sine law. Okay, another is the sine law. If suppose that these two magnetic R, P, Q are given to you. Okay, in a triangle, suppose that in a triangle P, Q and R, three forces are given to you. Okay, and the angle between these forces are also given. This is theta, this is beta, and this is alpha. Theta, beta and alpha, and you have to find the value of the magnitude of these forces. Okay, if one of the forces is not given to you. Okay, so this is given by sine law. This is given by sine law. What is sine law? We have studied what is cosine law. Okay, another is sine law. What is sine law? So according to the sine law, we can find the value of any force if the opposite angle are given to you. Okay, so how we are going to find? We have to use this formula. Okay, according to sine rule, suppose this is a force P. okay, and the opposite angle to this force P is alpha, okay, that is P over sine alpha will be equal to other force is Q, okay, and the opposite angle to the Q is beta, okay. So the Q over sine beta will be equal to R, and the opposite angle is theta, R over sine theta. So this law is called as sine law or sine rule, and by using this sine rule we can find the value of any forces. Suppose that this P is given to you, alpha is given to you, and also one of the angle is also given to you. So you can find the value of one of the magnitude of force, okay, by using the sine rule. And when this sine rule is applied to, coplanar and concurrent force system, then this is called as, Lami's theorem. Okay. Yes, Kavin is asking about the resultant formula for parallelogram. For parallelogram, that same formula will be applied. Suppose that there are two sides, P and Q. Okay. So for parallelogram, to construct a parallelogram, you have to complete this parallelogram. Okay. So suppose this is Q, this is P, so this will be Q and this will be P, and the resultant of this parallelogram will be R. Okay. Yes. So the resultant of the parallelogram is R. Suppose this is P, that is Q, and if we complete this parallelogram, so the resultant is represented by the diagonal. So this will be the resultant. Okay, suppose the angle between these two forces given to you, theta or alpha, whatever. Okay, so what you can do is you can apply this, you can divide this parallelogram into, yes, you have to divide this parallelogram into two parts. One is that you can see that this is also a triangle, okay, and the forces acting on the two sides of triangle are given to you, P and Q. Okay, so you can apply the same rule, that is R is equal to under root of P square plus Q square minus 2PQ cos theta to find the resultant diagonal. Yes, same formula will be used for parallelogram also. Yes. Okay. I hope that your question is clear to you, your doubt is clear. Yes. Now what I was telling you, when we apply the sine rule, for a system of force, which is coplanar and concurrent, okay, suppose this is a coplanar and concurrent system, okay, so given by forces F1, F2 and F3, and the opposite angles are also given to you, alpha, beta and gamma. Okay, so the theorem which is used for here is called Lami's theorem, and Lami's theorem is nothing but the sine rule, for coplanar and concurrent system. Okay, so for coplanar and concurrent system, the rule or theorem that we use is Lami's theorem. Okay, so same rule will be applied. F1, that is force F1, and the opposite angle is gamma. So F1 over sine of gamma will be equal to F2 over alpha, that is F2 over sine of alpha will be equal to F3 over sine of beta. Okay, so this is called Lami's theorem also when applied to coplanar and concurrent force system. Okay, so this was all about different laws of forces and different system of forces, and how to find the resultant of the force. Okay. Now, one important thing that I want to tell you, because this is the introduction class of engineering mechanics, and as we can see that your strength is reducing day by day in our lectures, and I don't know what is the reason behind that, but one thing I want to tell you, that you are asking for the video lecture which should be paid. Now this is a free lecture which is going on. So if in the free lecture your contribution, your participation is not that much, okay, as we can see from your strength is getting reduced day by day. In the first video lecture of thermodynamics you were around 100, okay, so your strength is reducing day by day. So what we can say that your participation is reducing. So this concept of free classes was only started to see your participation, so that we can come with the paid classes. So when in the free class your number is so much low, okay, so how we can start the paid class? Okay, so try to tell your friends to join our session, okay, to come for the session, to come for the live class, okay, because this is a free class that is going on our YouTube channel, and when we will come with the paid class and when your number will be so much low, so do you really think it will be worth for us to come with the paid class? Yes. So the reason is that you are not participating actively towards these free classes that are going on a YouTube channel, and you are expecting that we should give you the paid classes. Just think by yourself. Okay. Kevin, you can for coplanar and concurrent, that is actually for not coplanar, that is for non-coplanar and concurrent. Yes, you can see in the different videos also, you can visualize by yourself. Example of a tripod carrying a camera, that is non-coplanar and concurrent force. Okay. So this was all about the introductory class of engineering mechanics. Now let us solve some questions. Mohit Sharma asking till when this video will be available. This video will be available after we go offline also. Okay. So you can watch it later also. Yes. Now let us solve some questions. Let us solve some questions related to previous year questions. Yes. These are the previous year questions of SSC and RRB JE. Okay. So since this is the introductory class of the mechanics, okay, and seeing your participation for this session, okay, this is the introductory class. I don't need to teach you much because this is introduction of the mechanics. So I have given you brief introduction of the mechanics, different types of forces, system of forces, and the resolution of forces and loss of forces. Okay. Now we will be solving some previous year questions of RRB and SSC JE, so that we can understand what is the pattern of question, what are the topics from which questions are asked in the RRB and SSC JE. Okay. So let us start. This is the first question. In this question it is given that an object of weight 49 Newton is accelerated across a level surface at 0.20 meter per second square. You have to find the net force acting on the object which is having the gravity of 9.8 meter per second square. Okay, so you have to solve this question quickly and you have to tell the answer. Yes, you have to solve this question quickly and tell the answer. Rohit Yadav, in the next lecture of engineering mechanics, since we know that engineering mechanics is not having much content, okay, there are very few topics, so I will be covering only one lecture of engineering mechanics for the topics, in which I will be covering laws of motion and projectile motion. Okay, laws of motion and gravitation and projectile motion will be covered in the next lecture. Okay, and the last lecture will be covering some previous year questions of engineering mechanics. Okay, Now for this question, what is the answer? How we are going to solve it? Yes. Someone is saying 9.9, someone is saying 1. Suppose that there is an object which is kept on a level surface. There is some object which is kept on a level surface, okay, and the weight 49 Newton is acting downwards. Weight is equal to 49 Newton is acting downwards. Okay. Now it is saying that acceleration is given to you 0.20 meter per second square. Okay. Now we know that this weight is equal to m into g. Weight is equal to m into g. Okay, so from using this relation, we will be able to find we can find the value of m, that is mass. So the mass will come out to be around 5. Around 5 kg will be the mass, and the net force will be acting on the object will be equal to the net force which will be acting on the, since this object is having some acceleration of 0.2. Okay, so the net force will be equal to m into a. M into a. So this body will be moving by the force is equal to m into a. Okay, so the net force will be equal to m into a. So this will be equal to 5 into 0.2, that is 1. So the 1 Newton will be the answer. Okay, so option B will be correct. So this question was asked in your RRB JE 2015 paper. Okay, this question was asked in the RRB JE 2015 paper. Okay, so the answer is 1 Newton. Now I hope your doubt is clear. Now someone is asking, thank you so much for recommending your friends, and you can recommend your friend, you can tell your friend, tell them to subscribe our channel, tell them to like our, please also like this. If you want like this video, you can also like it. Okay, and if you have any query, you can also comment, but please your comment should be related to the topics that we are studying. Okay, and my request, don't use abusive content again on my video, otherwise don't need to come on this channel. Yes, so this is next question. Shyam pushes a box 10 meter on a horizontal surface by applying a 30 Newton force parallel to the surface. The work done is equal to, what will be the work done? So you have to find the answer. Yes, what is the work done? So we have moved on to the next question, that is question number 2. So tell me the answer for this question. Kevin, all the lectures that are going on our YouTube channel for Gearup JE Mechanical Course, all the lectures are only in English language. Okay, so as you can see that we are not using Hindi language in our videos. Okay, so as we know that most of the questions and most of the viewers are don't understand Hindi language. Okay, so we are trying to cover all the videos in English language only. Okay, yes, for this question we know that work done is equal to force into displacement. Okay, so the force in this case is equal to Shyam pushes a box which is kept on a horizontal surface. He is pushing the box. Okay, so the work done is equal to force into displacement. Okay, so the force is 30 and displacement is equal to 10 meter. So that will be 300 joule. 300 joule will be the answer. That was the easy one. Okay, a very easy question. Now this was again a question in RRB JE 2015. Okay, so you can see that the level of question is not that much tough in the RRB JE exam. Okay, next question. An object 10 kg is raised through a height of 2 meter. The work done is equal to, what is the work done? Again a very good question, an easy question. A body is raised through a height of 2 meter. Okay, so what is the work done? Yes. What is the work done for this case? Yes, what is the answer for this question? We have moved to the next question. So please tell the answer for this question. A very easy question. We know that in the previous question the work done was against a displacement. Okay, that is displacement is taking place in the horizontal direction. So work done was equal to F into ds. Okay, work done was equal to F into ds. Okay, all right. Now in this case work done is against raising a weight up to height of 2 meter. Okay, so what will the work done? Work done will be equal to M into G into H. That is will be equal to potential energy. Okay, work done will be equal to potential energy. It will be storing the energy in the form of potential energy. So it will be equal to 10 into 2 into 9.81. So answer will be 196 joule. So this was a very easy question. Okay. Again, this question was from RRB JE. Okay. Next question, a 0.5 kg ball is accelerated from rest to 12 meter per second in 0.3 second. Okay, the force which is applied on the ball during its motion is equal to. You have to find the force. Yes, Vela Marthi Rajesh, you are absolutely right. This time individual subjects will be asked, individual question will be from the individual branches. But I think if we have prepared for different exams like GATE exams or other exams, so the level of question you can see is very easy as compared to other competitive exams. Okay, so if it is from your individual subject, you will be able to score very high. Okay, because as you know that all the subjects of mechanical, if the question will be all the subjects from mechanical, so that will be very easy to score actually. Okay, because in the previous papers up to 2015, there were mixed paper from electrical, electronics, computer science and other branches also. Okay, that was actually very tough. Okay, so this time actually it will be very easy. Yes, for this question what is the answer? Now this force will be equal to, we know that force is equal to m into a, acceleration will be equal to dv by dt. Okay, so this will be equal to dv. What is the change in velocity? Change in velocity is equal to 12 minus 0 over 0.3. Okay, so this will be equal to 40. So force is equal to m into a, mass is given to you, mass is 0.5. So 0.5 into 40, this will be equal to 20. Okay, so 20 Newton will be the answer. This was again a very easy question. Again Vela Murthy is saying yes sir, but deafness will be more, I think sir. Yeah, actually the topics will be covered in depth in the RRB SSC JE, but the level of questions will be very easy. Okay, so you have to cover each and every topic that is given in the syllabus of RRB SSC JE. Okay, and we will be covering in our paid course. If we launch our paid course, we will be covering the complete topics, complete syllabus for RRB SSC JE. Yes. Next question, the time taken to perform 320 joule of work at the rate of 64 watt is? Suman Sharma, these are not time taking questions at all. These questions will be solved in just 1 minute. 1 minute is sufficient to solve this question. Yes, the question in the RRB SSC JE are not time consuming at all. It's just that you should know the concept, you should know the formula, and it should click at the same time and you are able to solve the question. Okay, so your concept should be cleared. Yes, also this time virtual calculator also will be given to you in CBT too. So that means a lot of calculation type question will be there, but you know that the level of questions are not that much tough. Okay, so it will be actually very easy for you to solve the question. Yes, for this question, what is the answer? Some of you, yes, most of you saying 5. Yes, I will not going to waste much time. We know that the power is equal to work done per unit time. Okay, so in this case, the unit of power is watt and the work is having unit of joule. So joule per second is equal to watt. Okay, so this power in the watt is given to you 64. This is given to you 320 over T. So time will be equal to 5 seconds. Very easy question, not wasting much time. Okay, so you can see that the questions are not tough in the RRB JE, but you said you should understand which formula you have to apply. So in the exam, that thing should click you at the time when you are sitting in the exam. Okay, so no matter how much you study, no matter how much you have covered the syllabus, but the thing is that at the time of your exam, it should click you. It should actually click you. The formula should come in your mind. That concept should come in your mind. Okay, then the question will take only 1 minute to solve. So next question. The quantity which is equal to rate of change of momentum is known as. So actually there are two questions combined here. For first question is that the quantity which is equal to rate of change of momentum is known as. This is the first question, and for this question you have to tell the answer. Quantity which is equal to rate of change of momentum. What is the answer for this question? Rate of change of momentum. Yes, this question, what is the answer? Rate of change of momentum, we know that F is equal to d mv over dt. So the rate of change of momentum is equal to, what is the rate? Rate always means per unit time. Okay, rate means per unit time. So when the rate is given, that means dmv by dt. So this will be force. Okay, so rate of change of momentum means rate of change of momentum per unit time, which is equal to force. So option D, force, will be the answer. That is actually Newton's second law of motion also. Okay, like rate of heat transfer. Suppose in the previous lecture you have studied heat transfer. Those who have studied heat transfer in the previous lecture, when we talk about heat, heat means a kind of energy which is flowing from one medium to other medium. But rate of heat, when we add rate of heat transfer, rate means per unit time. Okay, so the quantity which is equal to rate of change of momentum will be equal to force. That will not be equal to impulse. So the answer is equal to force, option number D. Okay, so those who have given option D as answer. Impulse, what is impulse? Impulse means when you hit a ball with the bat. Okay, when a batsman is batting and he hits a ball with a bat, that small amount of time for which the force acts on a body, that infinite small amount of time for which the force acts on a body is equal to impulse. Okay, so when you slap someone, suppose when you are slapping someone, okay, so that time of interval when we apply force on a person, okay, so the interval of time is very small. So when force is applied for a very small time interval, then it is called impulse. Okay, so the momentum impulse principle also say that F is equal to F into dt. F into t is equal to dmv. That is actually impulse. F into t is the impulse, product of force into time, but this time is very, very small time, very small time, infinitely small. Okay, so that is actually impulse. So I have given you two examples of impulse. Force is having the unit of Newton and impulse have unit of Newton second. So Suman Sharma, you are absolutely right. Now another question is given on this page only. What are the equilibrium condition to satisfied for a particle applied with system of non-coplanar and concurrent forces? Okay, non-coplanar and concurrent forces. Yes, non-coplanar and concurrent forces. What is the equilibrium condition for this? For this question, what is the answer? For this question? Yes, tell me the answer for this. Equilibrium condition to be satisfied for a particle applied with a system of non-coplanar and concurrent forces. So for this, the answer will be option number D. Option number D. That is summation of fx, fy and fz will be equal to 0 if the system of force is a concurrent force, and if it is concurrent and non-coplanar, then also the summation of moment in the different direction will be also be 0. So these are the equilibrium condition for non-coplanar and concurrent forces. Okay, so this I think you should. Non-coplanar and concurrent, I have told you the example also for non-coplanar and concurrent. A tripod carrying a camera, you can see that a tripod carrying a camera. Okay, concurrent means the forces are acting at the same point. Okay, when you suppose there is a camera, okay, there is a camera and you are holding that tripod. A tripod is holding a camera, so the forces on this camera are taking place on the same point. Okay, forces are acting at a same point, along a same point. Okay, so the line of action of force is same, acting at a same point, but this tripod can move in different plane. This tripod can move in different plane. This is not stable in a single plane. Okay, Kevin, I hope you understand that this tripod can move in different plane, in the x, y, z plane. Okay, so that is a non-coplanar and concurrent system. Okay, so I hope you have understood the example of non-coplanar and concurrent system. Yes. Next question, a circular disc roll on an inclined plane. The fraction of its total energy associated with rotation is? Force on a tip of pin, I think that will be concurrent. That will be concurrent force, Rohit Yadav, because the forces are acting at the same point. Alright, now for this question, tell me the answer quickly. Quickly tell me the answer. That is a very good question, but a lengthy one. This is a question from SSC JE, previous year SSC JE. Now you can easily understand the level of SSC JE, okay, and distinguish between the level of RRB JE questions. Okay, so for this question, tell me the answer. Yes, it is saying the fraction of the total energy associated with its rotation. Okay, so a circular disc is rolling. A circular disc is rolling, so the kinetic energy of the disc will be equal to, for translation it will be equal to half mv square. Okay, so this will be the, that is 0.5 mv square will be the energy associated with translation of the disc. Now when it is rotating, then kinetic energy of rotation will be equal to half into I into omega square, half I omega square. Okay, now this I, what is this I? I is the moment of inertia, and for the circular disk it is equal to half into m into r square. Okay, so the moment of inertia for a circular disk is equal to half into m r square. Okay, so this will be equal to half into half m r square. Now what about this omega? We know that v is equal to omega into r. So omega will be equal to v over r. Okay, so this will be equal to into v square over r square. So this will get cancelled. It will come out to be 1 by 4 into mv square. 1 by 4 into mv square. Alright. Now you can easily find from this the total energy and the current. Total energy will be equal to half mv square plus 1 by 4 mv square, and the rotational energy will be equal to 1 by 4 mv square. Okay, so the answer for this question will be, for this question the answer will be 1 by 4 mv square divided by 1 by 4 mv square plus 1 by 2 mv square. Okay, so after solving it you will get this value as 1 by 3. Okay, so option B, 1 by 3 will be correct answer. Yes. So 1 by 3 will be correct answer for this question. Yes. So those who have got option B as answer, they are absolutely correct. Those who have not, I think you have done some mistake. Yes. Next question, which of the following is the unit of energy? Which of the following is the unit of energy? Yes. Which of the following are the unit of energies? Yes. For this question, what is the answer? Quickly, tell me the answer for this question. Yes. Option number D will be the correct answer. Not wasting much time. The unit of energy is joule, and this is equal to Newton meter. And we know that 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Okay, that means electron volt is having the unit of joule and Newton meter. So these are all actually the unit of energy. These are all unit of energy in different forms. Okay, so option D is correct. Yes. Moving on to the next question. When a spring of a watch is wound, it possesses. When the spring of a watch is wound around, it possesses. Yes. When the spring of a watch is wound around, okay, suppose that when you are wounding around spring of a watch, what you are doing? What are you doing? You are actually increasing the. Yes, for this question, what is the answer? Quickly. When the spring of a watch is wound around, what will be the energy that the spring will possess? Yes. Option number C, potential energy. When we are storing the energy, when the energy is stored, okay, so that energy is stored in the form of potential energy. Okay, so when the spring is absorbing the energy, it stores the potential energy, and when the energy is released, then the potential energy gets converted into kinetic energy. Okay, so when the spring is absorbing the energy, when the spring of the watch is wound, then it will absorb the potential energy. Wound energy will not be the answer. The answer will be potential energy, option number C. Okay, so for this question, option C is correct. Next question. A particle with sliding down a smooth plane of 19.86 √t meter acquires a velocity of 19.86 meter per second. The inclination of the plane is. Yes, for this question, what is the answer? Suman Sharma, I think wound energy is just to confuse you in the question. As per my knowledge, there is no kind of energy like wound energy. Okay, that was only given the question to confuse you. Okay, so you know that these questions are such that they are just to confuse you in the exam. Okay, so correct answer is potential energy, not wound energy. Okay, yes, for this question, what is the answer? A particle is sliding down a smooth inclined plane. Okay, suppose there is a particle which is sliding down a smooth plane. Okay, he is having the angle of theta. Okay, now there is also a very important concept. Suppose this is acceleration due to gravity g. Okay, so if this acceleration due to gravity will also make an angle of theta with the normal. Okay, so if we resolve it in two components, this will be g cos theta, and this component will be equal to g sin theta. Okay, now in this question it is given that you need to find the value of theta. Okay, so by using the concept of kinematics, by utilizing the concept of kinematics, we know that v square is equal to u square plus 2 into a into s. The initial velocity will be 0 before sliding, so this will be 0. The final velocity is given to you 19.86. 19.86 square will be equal to 2 into a. What will be the acceleration due to gravity? The object is sliding in this direction. Okay, so the acceleration due to gravity will be equal to g into sin theta into what is the value of s? The s will be actually equal to the length of the inclined plane, and the length of the inclined plane is equal to 19.86 root 2. Okay, so after solving it and the putting value of g is equal to 9.81, you will get the theta is equal to 45.7 degree. Okay, now if in your exam, the answer is in whole number, that means if it is given that 45 degree, okay, so the correct answer will be 45 degree. But if it is given in this 45 degree, 42 minute and 18 second, okay, so you have to multiply this 0.7 45 degree and 0.7 into 60. When you will multiply this 0.7 60, this will come around 42 minute, and the remainder you have to again multiply by 60 and you will get 18 second. Okay, so it will be 45 degree, 42 minute and 18 second. Okay, so if in your exam the answer is in whole number, so the answer will be 45 degree, but if it is not, then the answer will be actually 45 degree, 42 minute and 18 second. Okay, so that will be the answer. Now next question. An elevator weighing 1000 kg attains an upward velocity of 4 meter per second in 2 seconds with uniform acceleration. The tension in the supporting cable will be. Okay, suppose that you are going in a lift, okay, and that lift is pulling you with a tension force with the help of the cables. Now you have to determine that tension force, okay, in this question. Yes, for this question, what is the answer? Solve this question fast. Okay, you are going in a lift and that lift is carrying you with the help of supporting cable, and you have to find the tension in the cable. Yes, for this question, suppose you are going in a lift and that lift is being pulled with a tension cable, tension T. Alright, and some weight will be acting downward. Okay, weight will be acting downward, which will be mg. Okay, now since the elevator is moving upward with a velocity of 4 meter per second, okay, so the acceleration will be equal to 4 minus 0 over 2, that is 2 meter per second square will be the acceleration. Okay. Now time is given as 2 seconds. Okay, so the acceleration is come out. Now the net force will be equal to T minus mg. Net force will be equal to T is acting in the opposite, in this direction, because that cable is pulling you upward. Okay, so the tension force will be more than mg. Okay, so the T minus mg will be equal to m into a. Net force is equal to product of mass into acceleration. So T will be equal to mg plus ma. So this will be equal to m of g plus a. Okay, so mass is given to you 1000, g is given to you 10, and a is equal to 2. So the answer will be equal to 12,000. Okay, so 12,000 Newton will be the answer. This was again a very easy question, but with a very good concept. Okay, so you have to apply the concept of free body diagram to solve this question. Yes. Next question, in order to double the period of a time period of a simple pendulum, the mass of its bob should be double or mass should be quadruple, or the length should be double or length should be quadruple. Yes, for this question what is the answer? You have to double the time period of simple pendulum. Yes, you have to double the time period of simple pendulum. We know that time period of simple pendulum is given by T is equal to 2 pi under root L by G. So time period is directly proportional to the length. Now in the first case it is saying that T1 by T2 will be equal to under root of L1 by L2. It is saying that T2 is equal to 2T1. Okay, so this is equal to 1 by 2 will be equal to, because T2 is equal to 2T1, time period is doubled. So the length will be equal to root of L1 by L2. So if we square both sides, L2 will be equal to 4 times of L1. A very easy question. Yes, option D will be correct answer. So those who have given option D, they are absolutely correct. Next question, which of the following theorem is used for the equilibrium of the body applied with 3 concurrent coplanar forces? A very easy question. I'm not going to take much time on this question. Yes, when the equilibrium of the body under 3 concurrent and coplanar forces. 3 concurrent and coplanar forces. Yes, I have told you in today's lecture only about a theorem called Lami's theorem. Okay, and that Lami's theorem, I have told you that Lami's theorem is applied for concurrent and coplanar forces. Okay, so the answer will be option number B. Next question, the forces which meet at one point and have their line of action different plane. Okay, forces which meet at one point and line of action different plane. What is that force called? Yes, forces meeting at one point and the line of action different plane. What is that force called? One point means concurrent, and line of action different plane means non-coplanar. Okay, so the answer will be non-coplanar and concurrent. And I have given you example today. A tripod carrying a camera is an example of non-coplanar and concurrent forces. Okay, yes, so the option B will be correct. Option B will be correct. Next question, which of the following have the same unit? Which of the following have the same unit? Yes, which of the following have same unit? Yes, Kevin, you are absolutely right. Yes, which of the following have same unit? Momentum and impulse. Momentum and impulse both have the same unit. of kg meter per second. Both have the same unit of kg meter per second, and we know that stress and pressure both have the same unit, Newton per meter square, and work and kinetic energy have the same unit of joule. Okay, so option number D will be correct. Okay, option D is correct. Next question, two tensile forces each of magnitude F are acting at a point perpendicular to each other, then the resultant force will be. Yes, two tensile forces each of magnitude F are acting at a point perpendicular to each other, then the resultant force will be. I've told you that the resultant is found by using this formula, R is equal to cosine rule, F square plus F square minus 2 into F into cos 90. Why cos 90? Because the forces are perpendicular to each other. Okay, so since the forces are acting perpendicular to each other, the angle between the forces is 90 degree. Okay, so this cos 90 is 0, so this will be answer root 2 F. Okay, so this was again a very easy question. So these were some questions for today's session. Okay, so see, these were previous year questions of RRB and SSC JE, and by going through the question we can easily visualize the level of questions in the RRB and SSC JE exam from engineering mechanics. Okay, so in the next lecture of engineering mechanics I will be covering projectile motion and laws of motion and gravitation. Okay, and that lecture will be held on 13th of March. Okay, so today is 11th, so day after tomorrow again I will come back with a lecture of engineering mechanics on the topic of projectile motion and laws of motion. Okay, so we will meet you on 13th of March. Till then, do like this video if you like the content given in the video. Also share it with your friends and subscribe our YouTube channel. So thank you and have a good day.